Hello, good afternoon, my dear students. So, welcome to one more amazing session from Infinity Lane. This is Suresh, Faculty of Chemistry from Infinity Lane YouTube studio. How are you all? Can you all able to hear me? You can see me. Please confirm in the chat box. Very good. So, today we are going to discuss about the topic alkanes, the most important topic from the hydrocarbons. Hydrocarbons, we have alkane, alkene and alkyne. In that alkane and alkene is more important than alkyne and alkane, so that we give more emphasis on alkene in the next session. So we are going to expect a very good number of questions even from the alkane. So I just want to conduct a special session for alkane. So before going for the details about this, I just want to talk about what Infinity Lane is doing for the students preparing for NEET examination. Here I just want to show you the frame case of the Ashrita, Akhil Verma, Hemadyuti and Satyanarayan. We have 4 different students here. You can compare the score from 2023 and 2024. And you can see Ashrita, she got 310 marks in 2023 and 661 marks in 2024. There is an increase in the 351 marks. And Akhil Verma, you can see 313 in 2023 and 658 in 2024, 345 marks in 2024. So that is possible. How it is possible? You can see Himadyuti also 310 in 2023 and 652 in 2024, and there is a huge increment of 342. You can see the scores. The score is almost doubled with Satyanarayan also 330 marks and 650 in 2024. There is a 320 marks is increased. So this score is almost doubled. This doubling of the score, you can see because they attended the classes with Infinity Learn, they followed the sessions and guidelines given by us. So even you are also doing, I am expecting in for 2025 you will be in the next slide, right? Not only these 4 students but also hundreds of students got the score like this. So all the best, my dear students. Prepare well and do the best and crack your NEET examination simply by attending our sessions. And please like our sessions, share with your friends and subscribe to Infinity Learn YouTube channel. And also I just want to say, Infinity Learn, we have the special app, that is Infinity Learn Meta app, where you can see live classes, mock test, create your own test, 24/7 doubt resolutions. And also you can see Infinity Learn, we are on the social media where Infinity Learn NEET YouTube channel is there, Instagram, Telegram channel and many more. And I always suggest you to join in the Telegram channel. The link is given in the description box. In that link you can just click it and join in the Telegram channel. In that Telegram channel, daily quizzes will be there and har din ka session schedule bhi dena hai, and session notes, session assignments and more things are available. And also you can see आजकल AI tool का हलचल ज़्यादा चल रहा है. So Infinity Lane is the first edutech platform uses AI tool into the education sector. And what we do with this, so AI enabled academic drive and goal settings, academic goal settings, set your academic goal and skill enhancement program. You will be having awesome lectures from an experienced faculty, and also test and paper analysis BA with in-depth performance and sessions and examinations and in-depth reports BA, and also self-study. In that self-study, learn, practice and revise for that, conceptual videos and mock test and practice test and flashcards for revision. And also last but not least, you will be having a doubt resolution powered by AI. Any doubt at any time, your answer you're going to get, a doubt is a click away. Yes, it is awesome and 24/7 and it is powered by AI, and while at you just scan the QR code and enjoy. And also India's largest scholarship examination. India's largest scholarship examination, score examination for grade any student. And why this is India's largest scholarship examination? Because this scholarship is provided worth of 1 crore rupees. That's why we say it is India's largest scholarship exam. And also you can see study setup and laptop and educational allowances and up to 100% scholarship. Everything is available. Link is there in the description box. You just click it and enjoy this score examination. And the specialty in this examination, you may be a student of Infinity Lane or maybe from any other institute, still you are eligible to write this score exam and you can do the best. And this examination is purely online and you can sit at home and you can enjoy it. Bachcho, and score registrations are opened in the description box. You just click it and enjoy score exam. All the best. And coming to NEET 2025 All India Test Series Pack. So what this test series wanted to give you, actually, so whenever you are preparing for any examination, it is required to assess properly how you are doing your preparation. For that, Infinity Learn is scientifically designed NEET 2025 All India Test Series Pack, which includes 27 AITS examination. In that, you are going to have 4-part test and 10 grand test, complete 27 AITS examination, completely based on NEET pattern, and also 20 different online NEET full syllabus mock test, and also 25 NEET topic wise PYQs and 3 physics chemistry books, along with video solutions on the app and detailed solutions and performance reports, in depth analysis will be given by Infinity Lane. अरे इतना सारे फैसिलिटीज इंडिया में सिर्फ आपको इन्फिनिटी लेन दे रहे हैं. सो उसमें क्या क्या चीज़ मिलेगा, हर चीज़ इतना मिलेगा. सो आपको 5999 तक है. बट व्हेन यू अप्लाई YouTube 50 कूपन कोड, you are going to get it for 2999. इतना सस्ता कौन देंगे, इन्फिनिटी लेन दे सकते हैं. So it's a limited time offer. You just click in the link available in the description box and you can enjoy this seamless NEET examination preparation. And talking about hydrocarbons, before going for the hydrocarbon, just a minute. So, bachcho, let's see the details about the hydrocarbons. Here, organic compounds contain only carbon and hydrogen are called hydrocarbons. These hydrocarbons are saturated or unsaturated. So, these hydrocarbons these are two categories, saturated and unsaturated. Saturated means carbon is completely bonded with all 4 sigma bonds. Unsaturated means they are having pi bonds. The pi bonds can be 1 or 2. I don't want to say it's open or cyclic, aromatic, non-aromatic, heterocyclic, homocyclic. I just want to confine to the alkane, alkene and alkyne. So, saturated, it is completely confined to CnH2n plus 2, they are called alkanes, and unsaturated they can be CnH2n waleko or CnH2n minus 2 waleko. So they are called alkanes, alkenes and alkynes. अगर कुछ डाउट है ना तो क्लास बीच में आप पूछ सकते हैं. Every doubt in the class is going to be honored. Okay, so let us go into the details about alkanes. They are also called aliphatic saturated hydrocarbons, where have the carbon with sp3 hybridization, and they are quite inert. 109 degrees 28 minutes or 109.5 degrees. Okay, and also carbon to carbon bond energies are also intermediate here, and also you can see alkanes can show chain isomerism. Alkanes can show chain isomerism. So the compounds have the same molecular formula but differ in the length of principal carbon chain are called chain isomers, and the phenomena is known as chain isomerism. Bachcho, so you can see N-butane, you can see the molecular formula C4H10. इसमें आपका 4 कार्बन का एक चेन होगा, that is isobutane 3 कार्बन का और एक चेन होगा. So this is N-butane and this is isobutane. इसका molecular formula C4H10 का है, and it is IUPAC name is 2-methyl propane or isobutane. So similarly, you can have C5H12. In that it is a pentane, normal pentane. It has 5 number carbons है, principal carbon chair में, and 2-methyl pentane, butane. This is isopentane, and 2,2 dimethyl propane. This is called as neopentane. Like that, you have a different carbon chain length. So they are going to have the corresponding alkane, and this kind of things you will come across in the physical properties of alkanes, where you can compare the boiling point. अरे if boiling point जो चीज़ है अगर molecular formula same होगा तो branching में inversely proportional होगा, ये very important का है. Okay, very important. And going to that, C6H14 have got 5 isomers like this. C6 का है ना, this is 5 isomers. मैं दिखाना चाहता हूँ आपको. So whenever you want to write these isomers, एक कार्बन कम करके एक ब्रांच लगाओ. ब्रांच लगाने के बाद ब्रांच का पोजीशन भी बदलो. So इसका आता है and now another one, 2 branches, so 5 carbon 1 branch, 4 carbon 2 branches. And let me say I could get one more important thing, and this is 4 and 2, and it is going to be, these two are going to be the same, na? So I just want to say this is going to be like this. And Newman and Sahar's projections, conformations of alkanes. Alkanes due to carbon to carbon bond rotation. So carbon is going to rotate its bond. Where is this? Carbon is going to bond its rotation. Carbon to carbon bond can be rotated. So when this single bond rotation is possible, bachcho, so it can have various types of conformers, that is called conformation isomerism. You want to say this is called a Newman projection. This is a ball and stick model, one ball and behind this another ball. So there are 2 carbon atoms that are shown like this. So these are the hydrogens that are present on the front carbon. You can see front carbon, and these are called back carbon. Okay. So when you talk about this, so these 2 hydrogens of the adjacent carbon atom are on the same axis. That is what you can say it is a eclipsed form, and adjacent carbon atom will be having a different orientations. Okay, that is called skew form, and opposite side, that is called as a staggered form. And this is another form, that is another mode of showing is called as Sahar's projection, and this is what is called Newman projection. So let's talk about isomers due to the free rotation of carbon to carbon single bond is called as conformers, and you talk about this as conformations of ethane. So when conformations of ethane is seen, this is the first carbon, behind that is another carbon. You can say this is a carbon bearing hydrogens, front carbon ka hai, and these are the hydrogens that is present on the back carbon, that is called one conformer. You can see, and you can see another conformer. And you can see. So what makes these 2 conformations? This is what you say eclipsed conformation. This is what you can say staggered conformation. Staggered conformation. So eclipsed conformation can be converted into staggered conformation. Staggered conformation is converted into eclipsed conformation. And eclipsed conformation repulsions ज़्यादा होगा, stability कम होगा. So energy ज़्यादा होगा. Because of these repulsions, you are going to have highest potential energy. So for every degree, 60 degrees angle of rotation of these two bonds, you are going to see the conformation. Eclipsed is converted into staggered, staggered is converted into eclipsed, eclipsed staggered, like that. And the bond and the barrier energy is going to be 12.5 kilojoules for ethane. That's very important. So which is more stable? Energy of dihedral angle. So stability, which is more stable? Staggered is more stable than eclipsed. Staggered is more stable than eclipsed. है ना बेटा? That's fine. Wonderful. Now let's talk about, this is the staggered conformation of ethane and this is your eclipsed conformation. The angle between the adjacent hydrogen atoms of the different adjacent carbon atom का hydrogen का जो angle रहता है ना, that is called as dihedral angle. Okay. Now let's talk about the butane, conformations of butane. When you talk about the butane, here it is CH3 and C and C and CH3 and hydrogen, hydrogen, hydrogen and hydrogen. You can see there is a ball. So this second carbon atom and third carbon atom is taken like this into the consideration. Carefully you see, this second carbon atom and this is the third carbon atom. Second and third is shown like this. So this second carbon atom has methyl groups and 2 hydrogen, and the third carbon atom is also having methyl group CH3 and hydrogen, like this. So this is one conformer and you can rotate like this. When you rotate na, so this is what is a fully eclipsed conformer and theta is going to be 0 and these are in the same axis. Okay children, आपका chart नहीं दिख रहे हैं, आपका chart नहीं दिख रहे हैं. Okay बच्चों, let me check, आपका chart नहीं दिख रहे हैं. हाँ. Now let's see. Gaussian, so 60 degrees angle is rotated so that methyl group is maintained. Any structure that is called Gaussian structure, it appear like a staggered, it is not staggered, and this is called Gaussian. The angle is going to be 60 degrees or 60 rotate karo, it appears like a eclipse. It is not completely eclipsed, it is said to be eclipsed only, but it is fully eclipsed because 2 methyl group on the same axis and it is eclipsed, and 2 methyl groups are absolutely maintaining 180 is the least repulsion and least energetic and the most stable, that is called fully staggered. That is what you say anti-conformation and is completely staggered. Okay, you can, when you see which is going to be the order of stability. Okay, NEET एग्जामिनेशन में आपका ये स्टेबिलिटी का वजह से क्वेश्चन पूछने का संभावना ज़्यादा है. सो यू कैन सी हियर एंटी इज मोर स्टेबल दैन Gaussian is more stable than eclipsed and fully eclipsed. Now stability energy, and both are inversely related. Here you can see the 2 methyl groups that are present here exactly maintaining 180 degrees angle, so that they are going to show the complete anti-conformation makes it is least repulsive, and it is going to be the more stable. That's very, very, very important indeed, right? And also, when you talk about this energy graph, so this is the energy and angle of rotation, and anti is least stable, and anti, when it is rotated to 60, it is going to be eclipsed, and it is going to be Gaussian again, and it is going to be fully eclipsed. You can see this eclipsed and is fully eclipsed का कुछ एनर्जी अंतर आ सकता. देखो, you understand? That is the way you need to understand this kind of graphs. And the least possible energy that is attributed to fully anti, and you are going to see completely 180 degrees angle. Okay, and moving ahead, methods of preparation of alkanes, it's very simple, and you can prepare it from unsaturated hydrocarbon. When alkene or alkyne is hydrogenated in the presence of nickel, or you can use nickel, or you can use platinum, you can use palladium, any catalyst, you are going to get a corresponding alkane. And this reaction is known as a Sabatier-Sanderson's reaction. Sabatier-Sanderson's reaction, Sanderson reaction. You can say it is a syn addition. It is a syn addition. Okay, and you are going to see example. This is a cyclohexene. When you add deuterium in the presence of nickel, you are going to get a product like this. Understand? You are going to get a product like this. Deuterium and deuterium. Got it? Clear? Wonderful. Now let's see from alkyl halides by reduction. Any alkyl halide on reduced, you are going to get a alkane. How do I go for the reduction? You can go for reduction by using zinc copper couple in acetic acid. You can use zinc in HCl, you can use, or sodium metal in ethyl alcohol you can use. You can use lithium aluminum hydride, you can use sodium borohydride, you can use triphenyl tin hydride, you can use many reducing agents you can use, right bachcho? Now you can see Wood's reaction. This is very, very important. फिलहाल 2-3 बार ये Wood's reaction का हिसाब से क्वेश्चन पूछा गया. So alkyl halide when react with sodium metal in the presence of dry ether, it forms its coupling reaction to form alkane. Now उसमें reactivity है primary alkyl halide, secondary alkyl halide, tertiary alkyl halide होगा. Tertiary alkyl halide do not participate in Wood's reaction, rather it prefers for the alkene formation. And alkyl halide, alkyl iodide is more reactive than alkyl bromide is more reactive than alkyl chloride is more reactive than alkyl fluoride. Okay, why dry ether is used? Dry ether is used to follow its free radical mechanism for the sodium. Okay, when methyl bromide is treated with sodium in dry ether, you are going to get you can use THF, you are going to get a C2H6. When ethyl bromide is used, you are going to get C4H10. Then methyl bromide, ethyl bromide are used, you are going to get a mixture of alkanes. So मिक्सचर ऑफ alkane सेपरेट करना मुश्किल बात है, क्योंकि इन लोगों का बॉइलिंग पॉइंट्स बहुत क्लोज वैल्यूज में रहते हैं. Are you getting or not? That's the reason why this Wood's reaction is not preferred for unsymmetrical alkanes, and it's not preferred for odd number containing alkanes, and methane cannot be prepared by this method. And Another case, if you use zinc metal instead of sodium metal, that you can say it is a Franklin reaction. That you can say it is a Franklin reaction. And decarboxylation, this is a very important from the decarboxylation. So when a carboxylic acid salt is heated with soda lime, mixture of calcium oxide and sodium hydroxide is called as a soda lime. When this mixture is added, so you are going to see the removal of carbon dioxide as in the form of sodium carbonate to give rise alkane. उसमें ट्रिक क्या होगा, अगर मान लो इसमें n नंबर कार्बन एटम होगा कार्बोक्सिलिक एसिड में, इसका जो अल्केन फॉर्म होता है इसका n1 नंबर कार्बन एटम्स होगा. So this particular decarboxylation is very important for descending series of carboxylic groups. And also rate of decarboxylation के एसिड का हिसाब से क्वेश्चन पूछना का ज़्यादा संभावना है बेटा. So rate of decarboxylation depends on decarboxylation. पहले जो ये बीटा कीटो एसिड ज़्यादा आसान से आपको डीकार्बोक्सिलेट होगा, beta keto acids, that's very important. And you can say rate of decarboxylation is depend on stability of carbanion, that's very important. ठीक है. And you can say the rate of decarboxylation is directly proportional to acidic strength also, you can say. This is very important. In the NEET examination, you will be asking a question, which of the following can be decarboxylated easily? Check point number 1, agar beta keto acid hoga to what is this beta keto acid? You can see this is your carboxylic acid, okay, COOH, and this is alpha carbon. ये बीटा पोजिशन में कीटो होगा, इसका सिर्फ हीट करने तो हो जाएगा. You need not have to add this carboxylic soda lime as well, so that you are going to get this. Okay, so it is going to be decarboxylated like anything. This is very important. More questions you are going to get from the NEET examination. Talking about Kolb's electrolysis, it is when sodium or potassium salt of carboxylic acid is electrolyzed in its aqueous solution, the product you are going to get is nothing but your carboxylic group is removed as carbon dioxide, and anode you are going to get a alkane, higher alkane, coupling alkane, and at cathode hydrogen gas is going to be formed. And also alkanes, physical properties is very important. So alkanes are almost non-polar, okay, and carbon atom 1, 2, 3, 4 are gases. Methane, ethane, propane, butane are gases. And also pentane to C17 are liquids we use as a fuel. And after higher 17 के बाद higher alkanes are solids, waxy solids. Paraffin wax is also there only. And density, the density increases with increase in the molecular mass. And alkanes are lighter than water, that is very important, क्योंकि इसका maximum density for alkanes is equal to 0.8 gram per milliliter. Okay, and all alkanes are heavier than air except methane. And the solubility, they are insoluble in water and soluble in organic solvents. Of course, alkanes themselves are solvents. And boiling point with the increase in the molecular weight. Rule number 1, boiling point directly proportional to molecular weight. अगर molecular weight same होगा तो, if molecular weight is same, मान लो ये आइसोमर्स हो सकते हैं. एंड रूल नंबर 2 इस्तेमाल करो, बॉइलिंग पॉइंट जहां पर ब्रांचिंग ज़्यादा होता है वहां पर बॉइलिंग पॉइंट कम होना का संभावना है. सो यू कैन से एन पेंटेन, आइसोपेंटेन, नियोपेंटेन का बॉइलिंग पॉइंट्स दिया हुआ. and melting points, it is just like boiling point. So I just want to say melting point is going to be directly proportional to this molecular mass, so that as number of carbon atoms increases, melting point increases. So but here alkanes with even number carbon atom have slightly higher melting point than these alkanes with the next odd number. So I want to say melting point, okay, you can say like this, see saw like structure you can say, okay, melting point temperature versus molecular weight, melting point and molecular weight, saw like zigzag kind of thing you are going to get it. So it is only up to carbon number 20, after 20 it is going to be the same. Okay, now let's talk about the reactions. So these are all the practice questions. In the Telegram channel I want to proceed these practice questions, so you can just go through that. Okay, and also you can see chemical properties is very important, chemical properties. ठीक है बेटा, and oxidation, you can go oxidation two types का तरीका है, complete oxidation, that is nothing but combustion. So the alkanes burn in oxygen, excess of oxygen gives rise carbon dioxide and H2O, and it is going to be exothermic, huge amount of energy is released, therefore alkanes are considered to be a fuels. And you can see CnH2n plus 2, when it is reacted with 3n plus 1 by 2 moles of oxygen gives rise n number of carbon dioxide and n plus 1 number of water. सो ये रिएक्शन आप इस्तेमाल कर सकते हैं यूडियोमेट्री करने के लिए एंड स्टोइकियोमेट्री में कुछ कुछ कैलकुलेशंस करने के लिए भी इस्तेमाल कर सकते हैं बच्चों. एंड आल्सो इनकम्प्लीट ऑक्सीडेशन, इन लिमिटेड सप्लाई ऑफ ऑक्सीजन it gives the carbon black and carbon monoxide. Okay, and one shot the total alkanes I just want to cover, and try to take this into the account, and you can go ahead with this beautiful explanation, and you can just grab your mark in the NEET examination. Or actually, and now so far we have seen complete oxidation, incomplete oxidation, abhi to catalytic oxidation, complete oxidation, incomplete oxidation, catalytic oxidation. So in the catalytic oxidation, when you talk about the methane is reacted with the oxygen, yes, in the presence of copper, in the presence of molybdenum trioxide. In the presence of copper, red hot copper or iron, you are going to get methyl alcohol, ethane, ethyl alcohol de sakte. And methane oxidizer MO2O3, molybdenum trioxide is the catalyst, so you are going to get formaldehyde, you are going to get formaldehyde. And also alkanes on oxidation in the presence of manganese acetate, okay, you are going to get its corresponding carboxylic acid. So you are going to oxidize in the presence of copper, you are going to oxidize in the presence of molybdenum trioxide and manganese acetate. So catalyst can change the fate of the product. That's very important. This is called selectivity process. Catalyst has reactivity as well as selectivity. Okay, selectivity is the best example over here. And also you can say substitution reaction. Alkanes है काफ़ी reactions नहीं है, alkanes react नहीं करते हैं, सिर्फ दो ही तरह के reactions करते हैं, लेकिन एक oxidation है और एक substitution है. Because carbon is completely saturated, you can't add anything. Rather, you can remove one hydrogen and you can replace with hydrogen. And halogen, or that is called substitution reaction, you can see halogenation, replacement of hydrogen atom by halogen from the alkane is a free radical mechanism. In that you can see the reactivity of these halogens, fluorine is more reactive than chlorine, than bromine, than iodine. And reactivities of ease of reactivity of hydrogen, you are going to see benzyl hydrogen is more reactive than allyl hydrogen is more reactive than tertiary hydrogen is more reactive than secondary is more reactive than primary. Okay, so we can say tertiary is greater than secondary is greater than a primary hydrogens we can say. And reactivity is very important. And first let us talk about the fluorination. fluorination, you can say CH4, when react with fluorine, you are going to get CH3F and HF. Even in the dark, it is explosive. That's the reason why we don't practice this reaction. It breaks like anything. That's the reason why we have to do indirectly. A lot of violent reaction. So you can add little bit of nitrogen to slow down that reaction. So you can use Schwarz reaction, because halogen exchange reaction, already one of the halogen can be replaced with halogen fluorine donor. And also you can say chlorination. So chlorination is in the presence of light, is also an explosive and vigorously violent reaction. Methane gives rise to methyl chloride. Methyl chloride gives rise to dichloromethane, and dichloromethane gives rise to trichloromethane chloroform. Chloroform can give rise to carbon tetrachloride. And this monochloride derivatives of alkane is also obtained by taking excess of alkane, limited amount of chlorine, right? And also bromination and iodination. Bromination is also fast reaction, but it is moderate, you can see, and you need to have a little bit of heat or in the presence of light. Whereas iodination is very slow and reversible. So reaction आगे बढ़ने के लिए आप ऑक्सीडाइजिंग एजेंट आयोडीन इस्तेमाल करना पड़ता है. Okay, anyways, halogenation is inhibited in the presence of oxygen, because oxygen prevents the formation of this free radical by consuming the free radicals. And you can see chlorination of methane mechanism. Mechanism of chlorination of methane. So mechanism of a free radical mechanism is always has three steps: initiation and the propagation and the termination. These are the three major steps that we can come across with the halogenation. So let's talk about the initiation. So initiation, chlorine and chlorine, there is a bond pair of electron, and this bond pair of electron is completely broken to half by homolysis in the presence of light. So in the presence of light, homolysis takes place, so to give rise chlorine free radical. And this chlorine free radical is going to abstract hydrogen from methane. So this is your methane. So this is your methane. And this methane is going to be extracted, it's hydrogen. Okay. Now you can see. And it is going to be. So methyl free radical is generated and HCl is formed. HCl and methyl free radical. Now this methyl free radical जो है ना, that is going to abstract one more chlorine free radical. सिर्फ initiate करने का light काफी है. The rest of the reactions are going to be as usual. Now it is going to be like this. Now methyl chloride is formed. Methyl chloride is formed and chlorine free radical is generated. You see how beautiful this reaction is. है ना? Now this methyl chloride and ये आगे बढ़ सकते हैं और एक साइकिल ऑफ रिएक्शन में डाइक्लोरोमीथेन बन सकते CH2Cl2 और आगे और एक प्रोपेगेशन में CH3CHCl3 फाइनली CCl4 होगा. एंड टर्मिनेशन में क्या क्या चीज हो सकते हैं, जो भी फ्री रेडिकल्स बचा हुआ, they are going to combine to give rise chlorine, and you are going to get methyl and chlorine free radical gives rise to CH3Cl, and also surprisingly you can see CH3 and CH3 you are going to get C2H6, and surprisingly you can see bachcho a small amount of ethane can be formed during chlorination of methane due to this termination step. समझ में आ रही क्या? सो बेस्ड ऑन दिस रिएक्टिविटी ज़्यादा है, सेलेक्टिविटी कम होगा, सेलेक्टिविटी ज़्यादा है, रिएक्टिविटी कम होगा, रिएक्टिविटी सेलेक्टिविटी प्रिंसिपल का हिसाब से. And also, and today we have seen types of hydrocarbons. In that we have seen alkanes, alkenes, alkanes. In alkanes we started where you just seen these type of isomerism, conformations, chain isomerism, conformation isomerism, and also we have seen the preparation, especially Woods reaction. You can see Grignard reactions, and also you can see decarboxylation reaction, and also physical properties, especially physical properties. We have a trick for the boiling point as well. And in the chemical properties, we have seen controlled oxidation, catalytic oxidation, complete combustion, and also we have seen free radical halogenation of alkanes. When you get a question based on these alkanes, definitely you can get types of monochloro derivatives and types of mechanism based Woods reaction, products, everything. And we are going to extend this kind of sessions. When you follow these sessions on a regular basis, I don't want to give a huge content. So I want to give you a content at a crystal clear manner, so that the answer supposed to be for your question is crisp and clear. And be clear what you are studying and prepare with Infinity Learn for your NEET examination. So hope you like this session, and please share this session with your friends and subscribe to Infinity Learn YouTube channel. Shivans Patel, after a long time I have seen you. How are you, beta? Happy New Year and all the best for NEET examination. फिर मिलेंगे every day one topic with Infinity Learn. Thank you very much. God bless you all. See you.